Okay, in continuation with our journey in pre-algebra on fractions and decimals, aka rational numbers, we're going to apply this with the order of operations, much like we did with integers last unit. So our goals in the next couple of days are going to be reviewing the order of operations, practice some problems with rational values, and apply that to geometry, and reflect, and this is a moral of today's story, when does a fraction make more sense to work with, and when does a decimal make more sense, okay? So really quickly, let's just go through the order of operations again, as we call it at Ravenscroft, GEMDAS, right? Old school people might call it PEMDAS. Please excuse my dear Aunt Sally. We call it GEMDAS because, as you know, the G stands for groupings, right? So let's go ahead and write in the grouping symbols that we all know and love. It's not just parentheses. Not just parentheses. We have parentheses are one type of grouping. We also have underneath square roots or radicals. Anything that is underneath there counts as being a parentheses. The top and the bottom of a long division bar. If you have stuff to do on the top and the bottom would be a group. And we have also seen absolute value work as a grouper as well, right? So anything that is in between the absolute value bars has to be done before you consider its absolute value. Is there any other ones? Oh, yeah, I guess brackets. Brackets, if you have brackets, that is grouping some smaller group. Those would be all of our groupings. Exponents are the next thing. So our exponents, anything that has an exponent on it needs to be taken care of. And the other thing that I would just be aware of is that when you have a square root, that falls into the exponent category, right? That falls into the exponent category because a square root is really taking something's half power. It does the inverse of a square. Then, of course, we're going on to multiply and divide from left to right. And then we add and subtract from left to right. Just like reading a book. Right, there you have it. That's a quick little review. Obviously, we did a lot of order of operations, GEMDAS problems last unit. And that's just a continuation. Now we just got to do it with fractions. All right, so let's just do this example problem together. All right, let me actually write out GEMDAS on the side of my paper. GEMDAS. Right? So do I have groups in this one? Yes, I do. So I'm going to go ahead and add these two decimals in the middle. 0.8 plus 0.4 is 1.2, still being squared, and I still have this division over here, negative 14 over 2. Any other groups to take care of? Well, if there was something to do on the top of this or the bottom of this division, I would have to do that alongside the groups, but I don't have to right now because there's nothing to do. It's already as simplified as it can possibly get, negative 14 over 2. So I'm going to go ahead and cross out the groups. Do I have an exponent? Yes, I do. Okay, I have an exponent of 2. 1.2 to the second power would be the same thing as 1.2 times 1.2, which is 12 times 12 with the decimal kicked over twice, which should be 1.44, right? Exponents are done. And if you notice, I'm still copying every step. Calculator ready form work is still a thing. Right now on the multiplication and division, do I have a division or a multiplication? And I do. Negative 14 divided by 2 is negative 7. Okay? And then I'm adding and subtracting, and I have to add 1.44 plus negative 7. Signs are different. Take the difference. 7 minus 1.44 should be 5.56. Excuse me. Check my math on that. 5.56. And the answer will be negative because the 7 has a larger absolute value. Right? So just a little bit of a review there on how to work these problems. Make sure that you are still showing your work in calculator ready form CRF, meaning that if you type this into the calculator, it comes out to negative 5.56. If you type the next line of work into the calculator, it comes out to negative 5.56. If you type this into the calculator, it comes out to negative 5.56. You see where I'm going with this, right? All of them equal negative 5.56, and it gets simpler as you work vertically. Pause the video now. I'll do the same. Let's see if we get the same answer on the next one. All right, we're back. And the important thing, and this is the first time that we've talked about this in this video lesson, is are you team fraction or team decimal on this particular problem? Well, on down to the left-hand side, I went team fraction, right? So I converted all of any decimal numbers, which was pretty easy in this particular case because it was 0.1. I converted that to a fraction. Now I'm good to go. And on the other side, written over here in pink, I went team decimal, and I had to convert these fractions to their corresponding decimals, which is sort of a math problem in itself. So in this particular case, if you went team fraction, you've got to make those common denominators of 30ths, and we do it again. And then we're only adding the top numbers. Remember, negative 77 30ths plus 18 30ths, which is a negative 59 30ths, which is good to go, or you could change that to a mixed number. Not too bad there. At least I'm dealing with all whole numbers, right? But if I convert to if I convert the fractions to decimals, I have to know that 2/3 is 0.6 repeating infinitely. That might not be the case for everybody. Might not have memorized 2/3. You have to know 3/5 is 0.6 or 6/10. That's probably a little easier to do, but still, not everyone might be able to do that off of the top of their head. Then you have a signs are different, take the difference with decimals. Okay, so we have to line up their decimal values. And if I have a 0.6 repeating plus 0.1, now I have a negative 2.56. The 5 is in place there, but the 6 continues on forever. And I'm going to be adding a positive 6/10 to it. I have to go over here and do some longhand subtraction on the side of my paper. 2.56 repeating, take away 0.60 repeating, becomes 1.96 repeating, and I have to remember that it's negative after all of that. And it just became a little more burdensome to work with decimals in this particular case, in my opinion, because of the repeating decimal. And also because you have to know what some of these decimals are, right? So in that one, I would advocate for team fraction, but you might be different, okay? Let's go ahead and do that same exact thing. Pause the video. I'll do the same, and then work this problem and see if we get the same answer. And we're back with this one. The only group in this particular case was underneath the radical, underneath that square root. 2.3 plus 6.7 comes out to 9, which is a perfect square. How convenient. Square root of that is 3, right? So grouping is done, exponent is done. Multiplication, division, I have a division. 8.12 divided by negative 2 is negative 4.06. Now we have a signs are different. Take the difference on those last two values of adding and subtracting. That's negative 1.06. Or negative 1 and 6/100ths, or negative 1 and 3/50ths. Now, this one, when I'm considering these numbers, they were all terminating decimals. They all stopped, and they were all fairly easy to work with. So, in that one, I would advocate for team decimal, right? They're all decimals already. Why convert them to fractions and see if I can work with those decimals? And I was able to with relative ease, right? Let's go ahead, last practice problem, or do I have another one after this? Yes, last practice problem. Let's pause the video and do this last one together. All right, whether you went team fraction or team decimal on this, if you were team fraction, you still had to follow GEMDAS, and if you were team decimal, you still had to follow GEMDAS. You still have to do the groups up top here. 15 minus 17, of course, is negative 2. 9 minus 5 is 4. And I have to add that to negative 3/5. They're already fractions, so I went ahead and worked with the fractions. That simplifies to negative 1/2 plus a negative 3/5. I need a common denominator before I add. Negative 5/10 plus negative 6/10. They're both negative. Signs are same. Take the sum, a negative 11/10. On the other side, though, if you went team decimal, negative 2 divided by 4 is negative 0.5. Plus, you had to know that 3 divided by 5 is 0.6. And then we have a signs are same, take the sum with the decimals. And you could really go either way with this one. The decimals weren't too difficult to deal with, and neither were the fractions. So that's just your choice of your preference there. So let's reflect and consider, when looking back at the last few problems, when was it better to use fractions, and when was it better to use decimals? Well, in my humble opinion, I'm not necessarily a pro, but when dealing with this stuff, okay, when was it better or easier to work with fractions? I would say when the decimals repeat. When you have a repeating decimal. And this is true anytime that you get an answer like 0.3 repeating. It's probably better to just work with that value as being 1/3, because I don't know about you, but I don't have enough time in my day to write infinite threes across my paper. And then you're going to have to round it or use bar notation, and it's not exactly accurate when working in more problems. When the decimals repeat, and you might say, or they are particularly long, meaning you can still have a terminating decimal, but one that goes, let's say, to the 10,000ths or 100,000ths place. And I don't really feel like working with that. If I have a comparable fraction, the fraction might be easier. When was it better to work with decimals, though? Okay, maybe when dealing with money, you communicate your answers with decimals to the hundredths place, to the nearest cent. Or maybe when common denominators are tough to find. So if you have really big common denominators, it's not really saving you that much arithmetic to work with a fraction than working just simply with the decimal. Because if you have really big numbers that are going above and below your fractions, when the common denominators are tough, then it might be just simply easier just to work with the decimals themselves, right? So there's no right or wrong answer to these reflection questions, but it's something to stop and consider before you work a problem. Okay? Now, when you were going through this and you're at this particular time, we just did a whole bunch of fractions and we just did a whole bunch of decimals in the last 2 weeks. What skills do you need to practice to become more accurate at this point in the unit? Adding, subtracting, multiplying, dividing fractions, adding, subtracting, multiplying, and dividing decimals. And then how would you rate your mastery on the 1 to 5 scale when following the order of operations? Did you disobey GEMDAS at any point in time? All right. So those are the last two things for class today, and we shall wrap it up. And I think the homework is homework 2.71, and we'll continue in our journey with some geometry and stuff later. See ya. Don't forget to like and subscribe.